The next paper is Artificial General Intelligence through Large-Scale Multimodal Bayesian Learning by Milch.
Thanks. All right, so this is going to be a less technical talk than the last two. And so the claim is that one path to achieving artificial general intelligence could be Bayesian learning from large amounts of data on the web. And to motivate that, let me start with one of the prime examples of a kind of thing we'd like AGI to do for us, which is to answer questions. And the range of questions people could ask a system is incredibly large. So here are a couple. How can I get from Boston to New Haven without a car? How many US Congress members have PhDs? Or here's a picture about how cold is it in there, based on what people are wearing. Now, if you gave these to a human being and gave them internet access, they could answer all these questions without too much trouble. But if you gave Google these questions, it would not give you the answers. It would have to combine information from multiple web pages, and also it would need to have broad and deep knowledge about the world. It would need to know, for example, that when you need to get from one city to another and they're this far apart, you're not going to walk. You're going to need to take some kind of transportation, that kind of general knowledge. And even more so in something like a picture interpretation, where you're saying, well, those are people in the picture, and they're wearing jackets, and that suggests something about the temperature. This is knowledge about a range of topics that ranges from transportation to clothing and so forth. So the question is, how can we possibly acquire all of that knowledge? And the proposal I'm making, which is, of course, not original, is that we should be able to learn knowledge from large amounts of data online, particularly now that the web contains not only text, but also images and video. And the general proposal is to learn by Bayesian belief updating. So maintain a probability distribution over models of how the world works in general. People tend to wear coats when it's cold, that kind of thing. And also the past, present, and future states of the world. For instance, there is a scheduled bus between Boston and New Haven. Questions like that. Or these people are in the US Congress. So this is not a fully fleshed out proposal, but I'm going to go through some of the issues that arise in thinking about how to make this a reality. The first one is just looking at what are the variables that we're going to be thinking about in our probability model. So this is a kind of complicated slide. Let's see. So at the bottom level, we have what we actually see. We get video data, we get linguistic data, and what this diagram is supposed to be is sort of a schematic of a Bayesian network or a probabilistic graphical model. And these are the observed variables. And then based on those observations, we want to make inferences about all these other things in here. So in particular, what we really care about is what I've called world history, which is the past, present, and future states of the world, and the tendencies which govern what happens in the world. And to reason about those things, we're going to also have to make inferences about, well, okay, I see some video. What's going on in this scene? What are the objects? What's occluding what? Things like that. And that's going to involve reasoning about what do objects look like? What do people look like? What do jackets look like? That kind of question. So those are also variables that I'm not going to know initially, but I'm going to, through looking at a lot of videos, learn what those things look like. And then there are also variables for language use. What words do people use in different languages for different concepts? How do people put sentences together? And all those things would also have to be learned. All right. So I've talked quite a bit about all these things you have to learn. What are you going to learn from? So one hypothesis dating back to the early days of AI is, well, we'll learn from text. And we'll read encyclopedias or something like that. And now on the web we have lots of text available, and it covers pretty much every topic we want to reason about. The problem is you're going to have no connection to sensory input. And so there are probably relatively few people here today who would think that you would learn from text alone. The other major thing that's been proposed is learning from embodied agents, whether they're physical robots or virtual robots. The great thing about this is if one thing is multimodal data, so you can connect linguistic and sensory input. The other thing is that you can actively manipulate the world you're in. So if you are uncertain about things, you can say, well, what happens if I look at the other side of that object? What happens if I try lifting this up? Does it move? That kind of thing. The difficulties with this are, for one thing, if you're using physical robots, then as people have pointed out, this can be expensive. Also, it's hard if they're just wandering around a lab to give them the kind of broad experience. I mean, how is a robot going to know about buses, really, unless you let it ride buses, which is something you're not going to do at the early stages. The other thing is virtual agents, and this is more promising in that you can give it broad experience. If there are buses in Second Life, it could take them. The question is, are you going to accidentally have some special properties in your simulation that don't generalize to the physical world? So if you're doing great in simulation, how much do you trust that you've really solved the problem? So what I'm proposing is learning from multimodal data on the web. It provides both broad coverage and multimodal integration. It does have drawbacks. It can be disjointed, trying to learn from a whole bunch of YouTube videos. How much will you really be able to interpret what suddenly happens in a music video, or even a video where there's cutting between scenes. And also you're forced to do passive observation. But still, at this point, I would guess that this is the best path we have. All right, so that's the data we're learning from. The next question is, well, are we actually learning everything from scratch, or are we going to build some things in? And I would argue that we actually want to build in some components. My argument for this is that children don't learn completely from scratch. We seem to have evolved abilities in the brain for doing things like spatial reasoning or reasoning about language. And also, there's been a whole lot of work in areas of AI on things like language processing. The idea of a parse tree. Do we want our system to invent the notion of parsing sentences from scratch? Or are we willing to give it that kind of idea originally? So I would say that we probably need built-in modules for things like spatial and temporal reasoning, physical objects, actually along the lines of what the speakers talked about in the last session, linguistic reasoning, and also reasoning about other agents, the ability to put yourself in another agent's shoes and use your own reasoning capabilities to say, well, if I were them, what would I do?
Just let you know 3 minutes.
Okay. So that's the built-in components. We're also going to have a whole lot of learned components. So really, our targets are to learn the history of the world, the present state of the world, and the tendencies. So the possible values for these world histories, they're going to be structures that have initially unknown sets of objects, initially unknown relations between them, and attributes, and also changing over time. So, okay, there's a lot of work actually in the probabilistic reasoning literature these days, including my own work on what I've called Bayesian logic, which is a probabilistic modeling language that lets you reason about unknown objects. What you need for that is prior distributions over what's going on in the world. And that's really what these tendencies are. It's an encoding of what your priors are about what's going to happen. So I'd say that the most promising way of representing this is with fusions of probability and logic. The field that is working on this in the AI community goes by names of statistical relational learning or relational probabilistic models. And there's an edited volume from MIT Press just last year, which I'd recommend to anybody who's interested in learning more about this. The difficulty here is that the types of objects and the predicates and the dependencies in these models are also initially unknown. Right? We don't know what the model is initially. So we're going to need another layer on top of this. In our probabilistic model, there's priors over how the world tends to behave. And this we really have not a great idea how to do. I've referred to one sort of path towards this, which is Dirichlet processes, which are something that's sort of a hot topic in probabilistic AI these days. It's a clustering model that lets you not say ahead of time how many clusters or object types or predicates you need in advance, but you can do Bayesian reasoning to figure out what's the best number of clusters to explain my data. Since we're short on time, I won't say much more about that. All right, so you want to do all this learning, what kind of algorithms you're going to use, lots of options out there in the literature. You're probably going to want to parallelize your interpretation over documents, but still, it's really unclear how to scale this up sufficiently. And I see probabilistic inference as the major challenge for at least the perception and state estimation side of AGI. Okay, so how are we going to make progress on this? I'd say that we should be able to demonstrate progress to the broader AI community even before we have full-blown AGI. And one way that we should be able to do this is by showing year-to-year improvement on some of the real evaluation data sets that people use in sub-communities. So for example, there's a Caltech data set on object recognition. There are various challenges sponsored by Trek and the ACE automated context extraction workshops on things like resolving co-reference between phrases in text. There's something called the Pascal Textual Entailment Challenge, which is about telling whether one sentence in a natural language entails another, which involves a lot of reasoning about, well, if it's cold, does that entail that the temperature is low? That kind of question. So if we're building an AGI system, even if we haven't solved general AI, we should be able to gradually improve on these data sets. Another thing we should be able to do is serve as a resource for more finely tuned but shallower systems. Right now, a lot of these systems use resources like Psych or WordNet to get some kind of world knowledge. Well, can we learn things that are better than Psych and WordNet for serving as resources? Another way that we can interact with the broader AI community so I think it's a promising path. Thanks.